Hey guys, welcome to Unit 9, Lesson 5. This lesson is more practice of Lesson 4, and you can use the calculator for the warm-up in this lesson. So let's get started with the warm-up. It says a particle moves along the x-axis with its position at time t given by x of t equals t over 1 plus t square, where t is measured in seconds and x in meters. So A is asking us to, it's a two-part question actually. It's asking us to find the velocity at time t and at t equals 2 seconds. So we are going to, remember your velocity is the first derivative of your position. So we're going to take that and then we're going to plug in t equals 2 into the velocity equation. So let's find v of t. Remember, we're going to be using the quotient rule, which is a prime b minus ab prime over b square. So your a is this and your b is this. Your a prime is just 1, your b prime is 2t. So that's what we're going to do. So just substitute in. So it's going to be 1 plus t squared squared. And in the numerator, I have 1 times 1 plus t squared minus t times 2t. So if I can choose to clean it up, like simplify it, or I can just substitute 2 for it and simplify it. So 1 plus 2 squared is 4 minus 2 times 2 times 2 is 4 over, remember again, it's a calculator question. You could put that in the calculator, squared. So this would be 5 minus 8 is negative 3. 4 plus 1 is 5. 5 squared is 25 meters per second. Okay, part B. It says when is the particle at rest? Again, go back to your definition. When is the particle at rest? It is at rest when my velocity is equal to 0. When is it moving right? When my velocity is greater than 0. And left is when velocity is less than 0. Justify your answers. We already wrote the explanations. Now we just need to do this work. So I'm going to take I already found my velocity up there. I'm going to clean that equation up a little. So what do I get? I will get t squared minus 2t squared, which would be what? 1 plus t squared minus 2t squared would be negative t squared over 1 plus t squared squared. I'm going to set this equal to 0. If I cross multiply this, I'm left with 1 minus t squared equal to 0. I'm going to say t squared is equal to 1. T is equal to square root of 1, which is just 1. I'm going to ignore the negative. Usually when you take the square root, you have plus and minus. I'm going to ignore the negative because we're not taking negative time into consideration. So t equals 1 is it. That's when it's at rest, right? So now what do I need to do? I need to find when it's moving right to the left. So I'm going to draw a number line, my velocity number line. I'm going to cap it at 0. And the other number that is of relevance here is 1, right? So I want to find out when it's moving right and left. So I'm going to pick a number from each interval and find out if it's a positive number, it's moving right. If it's a negative number, it's moving left. So let's say I picked a half from this interval, and if I substitute into the velocity equation, I get a positive number. You can use the calculator and find it. Similarly, if I pick a negative number in my interval from 1 to the right of 1, I end up getting a negative number. So it's moving to the right here from what? From 0 to 1. And it's moving left from what? From 1 to infinity. Part C. Find the displacement of the particle during the time interval of 0 and 4. So displacement is basically difference where you ended up from where you started, right? So what do? it would be x of 4, that's where I'm ending, minus x of 0. So x of 4 is, again, you can use your calculator, 4 over 17 minus 0. So it is 4 over 17 meters. Part D, it's asking us to find the total distance traveled by the particle between 0 and 4. So let's think about it. Our number line, our velocity number line, we were changing direction at 1 because my particle was going from moving right to moving left. So I want to find the total distance. So if I find the displacement from 4 to 1, and then from 1 to 0, right? And I take the absolute value of it and add up that total trip because I'm looking for the total distance. And I just wanted to find the displacement from 4 to 1 because I already know my particle is what traveling left, and I don't want a negative answer. So it would be what? X of 4 is, you can actually substitute into the calculator. It's 4 over 17 minus 1 half plus 1 half minus 0. And this would be what? 13 over 17. So that's your total distance traveled, meters. Oops. Meters. Part E. It's asking us to find acceleration at time t and at t equals 3 seconds. So remember, acceleration is the first derivative of your velocity or your second derivative of your position. So my acceleration is gonna be, my velocity was this function, so it's gonna be, it's again, I'm gonna write a prime b minus ab prime over b squared. If you're gonna write your a prime on the side, it would be negative 2t. B prime is gonna be, you're gonna do the chain rule here, it'll be 2 parentheses 1 plus t squared to the first times, and then the inside 2t. So which, if I simplify, it's 4t times 1 plus t squared. So we already know our a prime and b prime, and we are going to just substitute in. So a prime is negative 2t, and my original b was 1 plus t squared squared minus a is 1 minus t squared, and my b is 4t 1 plus t squared, right? I know it looks really ugly, but it is what it is. So, and the denominator is this squared squared, which would be 4th. So I want to find it at a of 3. Remember, it is a calculator question, so you can just substitute in 3, and I will get a value of 0.036 meters per second square. Again, remember, this is acceleration, so it's going to be second square, and we round to 3 decimal places in this class. So make sure all your answers are always rounded to 3 decimal places. Part F. When is the particle speeding up, slowing down? Justify your answers. So I do that. So speeding up, I'm just going to, is when your velocity and acceleration have same signs. Slowing down is when velocity and acceleration have opposite or different signs. Whatever you want to write, right? So I already know from part B, I have my velocity number line, and I'm going to come write it here. So that's my velocity number line. And I knew at 1 it was changing direction, it was going from positive to being negative, right? Or moving from, it was moving right and then it started moving left. So that was my velocity number line, v of t. I'm going to right underneath draw the acceleration number line. I'm going to change colors. so that it's easier for us to compare the two. So always try to do that. Put your if you're comparing them, finding out the speed, so try to put them underneath. It's easier to compare. Okay, so now I already have my acceleration equation. This is like really ugly looking, but if you think about it, it's really not bad. And if you simplify it, you will get a of t is equal to 2t cubed minus 6t over 1 plus t squared cubed. So if I set this equal to 0, my denominator goes away and I'm left with 2t cubed minus 6t equal to 0. I'm going to factor out the 2t, so I'm left with t squared minus 3 equal to 0, and my t is equal to 0, and t squared equals 3, so t is equal to rad 3. Usually we put plus and minus in front, but we're going to ignore the negative because time is positive. So these are our two critical 2 points, or where my acceleration is equal to 0 at 0 and rad 3. If you were to put exactly write it under, rad 3 is actually a number greater than 1, so it's going to go right here. So now I'm going to pick a number in each interval and plug into my acceleration equation, because this is my acceleration number line. So let's say I pick 1. So if I pick 1 and I substitute in here, I will end up with a negative number. This is a negative number, and if I pick a number greater than rad 3, it could be 2, 3, 4, any number, and you end up getting a positive number here. So now let's compare. So my first is from 0 to 1. It's positive, and here my acceleration is negative. So what's happening? It is opposite signs or different signs, so it is slowing down. So slowing down, I'm going to change colors and write that down. So slow down, and I'm going to write speed up. Here's all the intervals, speed up, right? So slowing down, because from 0 to 1 they have different signs, so it's slowing down. Now from 1 to rad 3, do you see 1 onwards velocity is negative? So if your 1 was here, from 1 to rad 3 it is negative. It has the same sign, means it's speeding up. So from 1 to rad 3, it's speeding up. So now rad 3 onwards, again your velocity has a negative, but your acceleration has positive. It has opposite signs, so it is what? Slowing down. So from rad 3 to infinity, it's slowing down. So that was our warm-up. So let's get started with numbers. So here we are given a position equation. X of t equals 2t cubed minus 9t squared plus 12t minus 4, and it's asking us to find all t for which the distance x is increasing. Remember, change in distance means that's your velocity, it's your first derivative. So I'm going to find my v of t, which would be 6t squared minus 18t plus 12. So if it's increasing, means my velocity is what? Greater than 0, right? So I want to set it equal to 0 and solve. So I can factor out the t, 6, and then I'm left with 6t squared minus 3t plus 2. I can divide by 6 on both sides. I'm left with t minus 2 and t minus 1. T it off, and you get t is equal to 2 and t is equal to 1. So let's sketch our velocity number line. I'm going to start at 0 because we don't deal with negative time. So, and then it's at 0 for t equals 1 and 2, and now I'm going to pick a number in each interval because I want to find when the distance x is increasing, which is when my velocity is increasing. So I'm going to pick a number. Let's say I pick a half in the first interval. So if I substitute half into my equation, I will get a positive number. Remember, it's my velocity number line, so I'm going to substitute in my velocity equation. Then if pick any number between 1 and 2, let's say 1.5, 3 halves, and I will end up with a negative number in there. And if I pick a number greater than 2, I end up with a positive number in that interval. So it's asking me when is it increasing. So it's increasing in 2 intervals, when t is between 0 and 1, or t is greater than 2. If I was to write an interval notation, it's going to be 2 comma infinity. So part B, it says find all t for which the velocity is increasing. Again, change in velocity means your rate, which is your acceleration. So I'm going to write wherever my acceleration is greater than 0. So let's do that. So I'm going to find acceleration is the first derivative of your velocity. It's going to be 12t minus 18. And if I solve it for t, I get 3 halves. So I'm going to draw my number line because I want to find where is my acceleration, velocity increasing, or where my acceleration is positive. So, and again, I actually want to draw it right underneath my velocity number line so I can compare it for my future questions. So 3 halves would be a number like right in middle of 1 and 2, right? So it'll be like here. So that's 3 halves. So if again, pick a number between, this is my acceleration number line, pick a number between 1 and 3 halves. Let's say 1. I'm going to substitute in here. I do get a negative number, right? And if I substitute a number greater than 3 halves, let's say 2, 12 times 2 is 24, minus 18 is positive 6. So positive 6. So I want to know where is it increasing. It's increasing from 3 halves onwards. C. Find all t for which the speed of the particle is increasing. Again, we're talking about speed. Your speed is increasing when your velocity and acceleration have the same signs. So let's compare here. I'm going to actually use a highlighter. So from 0 to 1, and let's say 1 is here, like over here. Right? 1, that's 1. And it's a highlighter. So between 0 and 1, it has opposite signs. So it is decreasing. From 1 to 3 halves. So 1 to 3 halves, if you see, it's negative. 1 to 3 halves, it's negative. So it's the same sign. So my speed is increasing from 1 to 3 halves. And then if I look at 3 halves onwards, it is 3 halves to 2. It has opposite signs because remember, it's negative here. It's all negative here. And from 2 onwards, it has positive. So from 2 to infinity, it is increasing. Right? The speed is increasing. So part D, it says find the speed when t is equal to 3 halves. So I'm just going to substitute 3 halves in my velocity equation, and I'm going to get, this is what you're going to do. I'm just 18 times 3 halves plus 12. I'm going to get negative 3 halves. But remember, speed cannot be negative. It's the numerical value of velocity. So it is going to be just 3 halves. The negative velocity is negative and positive, because if it's negative, the particle's moving to the left. Right is it when the velocity is positive. So always remember, speed is always positive. Part E. Part E. So find the total distance traveled on the time interval. Again, I want you to be very careful. If I was asked displacement, all I would have done would be x of 4, x of 4 minus x of 0, and that would give me my displacement. But here we're being asked the total distance, so we need to take into consideration anywhere we change direction, some of our trip might have cancelled out. So we want to do is what? Find the absolute value of our displacements and add them up. So let's look at our velocity number line. We know we changed direction at 1 and 2. From 0 to 1 it was positive, then negative, and then positive, right? So this is where we change direction. So we are going to end up actually do 3 displacements and then add them up. So I'm going to split this up into and I'm going to use my original equation, my position equation, from x of 4 minus 2x of 2. I'm going to find the distance between them and take the absolute value of it, add it up to x of 2 minus x of 1, and then what am I left with? The last one is x of 1 minus x of 0. Oops, sorry about that. X of 0. So x of 4 is, if you substitute 4 into your original equation, you will get 28 minus x of 2 is 0, plus 0 minus 1 plus 1 minus negative 4, which is 28 plus 1 plus 5, which is 34. So my total distance traveled is 34. There are no units given, but if they were given, this would have been miles, meters, anything along those lines, right? So we're done with this lesson. So finish up the remaining lesson for homework, and if you have any questions, please feel free to reach out.